In today's high-tech world, staying plugged in has never been more important. Wired to a home's electrical system, a standby generator automatically powers up in the event of an outage. It assumes the electrical load until the public utility system comes back online. With your own standby generator, a power outage is never a crisis. Production starts with the stator. It's the stationary core of the alternator, the part that converts energy from the motor to electricity. A press compacts 100 or more laminated steel discs to create the stator core. Machinery unwinds steel banding and wraps it around the stack to hold the core layers together. Machinery lifts the stator core out of the assembly device and transfers it to the next station. Here, an automated system insulates the numerous slots in the core. As the core turns, a machine cuts, forms, and inserts synthetic insulating fabric into each slot. Meanwhile, at another station, an automated system winds copper wire onto a mandrel. The slots in the mandrel are the same size as the insulated slots in the core. This configures the copper windings to fit the core slots. But first, a technician slides the copper coils onto a threading tool. This tool maintains the configuration of the coils to prepare them for installation in the stator core. They wind more bundles of copper wire. Once all of the windings have been correctly arranged on the threading tool, the technician is ready to transfer them to the stator core. He places the stator on top of the threading tool and activates a hydraulic device that pushes the wires up through the tool and into the slots of the stator core. The device retracts and he removes the stator. The copper wires transform the stator into an electromagnet, which is critical for electrical generation. He trims the ends of the wires and sets the leftovers aside for recycling. He slides insulating sleeves onto the ends. Then it's into the lacing machine. This machine crochets a string wrap around the bundles to hold the wires together. It also pulls in any loose strands to keep them from snagging on generator components. With the wiring precisely wound and wrapped, this important generator component is ready for the finishing touch, a clear varnish. The lid closes on the tank and a vacuum pulls air out. The tank then fills with clear varnish to coat the stators. The varnish fills in any gaps in the windings. They transfer the stators to an oven and bake on the varnish. Once hardened, the varnish insulates the entire assembly. The next technician connects the stator lead wires to a testing machine. The machine applies high-voltage pulses to the wire windings and monitors the output for anything that could cause generator failure. The stator passes the test. A technician now positions an outer casing and an end cap on top of the stator, followed by a steel pressing plate. A hydraulic arm then provides the muscle power needed to fit the casing and cap snugly to the stator. Coming up next, the generator stator joins the rotor and engine, and the result is purely electric. To produce the alternator's rotating part, the rotor, The technician stacks laminated steel discs to the same height as the stator core. He lubricates the opening in the center of the discs. He inserts a shaft, and a press pushes it into the stack to complete the installation. Powered by the generator engine, this shaft will spin the rotor. The technician installs steel rods to maintain the disc's alignment, and then removes the rotor from the assembly device. He fits more rods to it on a slight angle. They'll act as conductors and stabilize the rotor's electrical output. He slides aluminum caps onto both ends of the rotor. Then it's over to an automated welder. The machine grips the rotor at both ends and slowly turns it, as a robot welds both caps to the rotor body. Welded in place, the caps secure the aluminum rods. The aluminum solder used in the weld is conductive and will create an electrical connection. The technician unclamps the rotor from the welding machine and then tucks insulation into slots on the sides. The rotor then goes for a spin in a machine that winds bands of copper wire around the insulated sections. These wires will act as electromagnets and help produce electrical current. They tie string around the wire, add bearings and a copper collector ring, and bake an insulating varnish onto the entire rotor. They're now ready to assemble the standby generator. Using a lift, the technician lowers the engine into position. He joins the rotor shaft to the engine crankshaft. To secure the assembly, he drives a very long bolt through the rotor to the crankshaft and tightens it to a specific torque. Next up is the stator. It'll provide a magnetic field to advance the flow of electrons in the rotor. The technician slides the stator onto the rotor. A steel end bracket is next. It aligns the rotor and stator. He forces the bracket into place. To secure the alignment, he installs 4 long bolts from the end bracket to the engine adapter plate. He anchors the stator and rotor to the generator base and adds special rubber mounts under the supports to buffer vibrations. He attaches a motorized carbon brush to copper rings on the rotor shaft. The brush will collect electricity from the shaft and transfer it to the generator controller. He secures it to the end bracket with screws. He connects the wiring harness that moves electricity from the brush to the controller. He links the other end of the harness to the engine. He plugs in a sensor to monitor oil pressure, and he makes all the other electrical connections. Next up is a panel through which he runs some of the wiring. It acts as a separator to prevent entanglements and also supports the fuel regulator. Other parts include a muffler to help dampen engine noise and a controller that converts generated power to the correct voltage. The assembly of this standby generator is complete. The technician fuels up and runs it first at partial capacity, then to the max. The test confirms that there's no wavering in electrical output. Once encased in a neutral-colored, corrosion-resistant shell, the standby generator blends into the background. But in a power outage, its contribution will definitely be noticed.